Good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a worksheet on pure rolling on inclined plane. So axes are like this. We have an inclined plane of height h, angle theta, coefficient of friction is mu, and a rigid body is made to roll starting from rest from the top, and at some intermediate stage its velocity is v, angular acceleration is alpha. So there are certain questions based on this. The first is we need to find normal reaction between inclined plane and its sphere. So that is going to be mg cos theta because motion is taking place along x-axis. So there is no y component of the center of mass of the sphere. Then is find ACM for pure rolling. So from calculations in my previous videos, I have shown that ACM is g sin theta upon 1 plus k square by r square. Then we need to find alpha for pure rolling. So ACM is R alpha, so alpha will be ACM by R, so that is gonna be 1 by R g sin theta upon 1 plus k square by R square. Then we need to find time taken by body to move from A to C. So suppose this total length is L, so time will be root 2L by ACM using second equation of motion. So we can write it as 2L by g sin theta 1 plus k square by R square. So that will be, we can take L as h upon sin theta. So that will be sin square theta over there, and since it is the root, so it will be 1 by sin theta root 2h by g 1 plus k square by r square. I have omitted all the derivations here because in this worksheet I just aspire to give you all the standard facts, all the concepts and formulas directly related to solving the questions. In case of derivations, you can see my other concept videos for that. Next is find speed of center of mass at the bottom. So it is equal to root 2gh by 1 plus k square by r square. Then is find total kinetic energy of body at the bottom. So using conservation of energy, we can say that here the entire potential energy will be converted into total kinetic energy. So that will be mgh. Next is find ratio of translational and total kinetic energy at the bottom. So translational kinetic energy will be half mv square. Total kinetic energy is mgh. So that will be v square by 2gh. Using expression of v square, we can say that it will be equal to 1 upon 1 plus k square by r square, or r square upon r square plus k square. Then we have find ratio of rotational and total kinetic energy at the bottom. So this will be 1 minus this thing, and after simplification it comes out to be k square by k square plus r square. Then we need to find ratio of translational and rotational kinetic energy. That will be r square by k square. Then we have a question that a ring, disc, hollow sphere and solid sphere are released from rest from A. Then is which one will reach bottom first? So obviously solid sphere reach the bottom first. Then is which will have maximum speed at the bottom? Here it is also the solid sphere. Then is which will we have maximum acceleration? Again solid sphere. Which have maximum alpha? Again solid sphere. Maximum omega? Again solid sphere. And which will have maximum ratio of translational and rotational kinetic energy. So again we have solid sphere. So you've seen that we have discussed 15 questions in a time span of, let's say, 4 minutes. So these videos are just an optimization tool for you so that you can cross check your preparation. We have included every basic concept, every effect, every possible manipulation using standard results so that you can optimize your efforts, time and energy. Thank you and have a nice day.